and welcome to all our lovely grade 10 mindsetters. You are tuned into the channel that aims to only give you the best learning experience. And of course, we've got the maths show today, and you are tuned in with myself, Queen Matoso. But I'm not alone. Natasha, how are you?
I'm very well, thanks. Nice to see a brand new presenter on the show. Good luck, Queen.
Thank you. Natasha's our lovely teacher that will be going through the show with us today. And guys, remember that this show is all about you. So all you have to do is please get in touch with us, and that is through our social media platforms. Facebook, you can catch us on Learn Extra, or you can also catch us on Twitter at Learn Extra with an X. And remember, guys, that we also have a lot of study material that you guys can download, and that is on our website at learn.mindset.co.za. So please get typing, get in touch with us. We love to hear from you. This show is always about you, as I always say. But without any further ado, let us get straight into things. Natasha.
All right, guys, so today we're looking at analytical geometry. We've looked at geometry in the last couple of weeks, and now we're going into analytical geometry. And specifically, we're going to look at the distance formula, the midpoint formula, and then finding the gradient of the line and finding the equation of the line. But I quickly want to remind you about your challenge question. You're told that PQRS is a quadrilateral. They give you the points of P, Q, R, and S. And then you need to find the length of QR. Part B, find the gradients of PS. Part C, find the midpoints of PR. And then the last one, is PQRS a parallelogram? And you need to substantiate, give a reason why you think it is a parallelogram or why you think it is not a parallelogram. All right, guys, just a reminder, some of the formulae that you will be using for the rest of today's lesson. These will be given to you on your formula sheet, but remember, if you haven't practiced enough, then you won't know when to use them. So you need to practice your analytical geometry to understand when you need to use each of these formulae. You've got the distance formula. So if we look at finding the distance of some line segment AB, it's equal to the square root of xb minus xa all squared plus yb minus ya all squared. So just a reminder, you'll be given a set of coordinates, the x and y at point A, and then you'll have the x and y coordinates at point B. And you would use that distance formula in order to work out the distance between your 2 points. The midpoint formula helps you to find the midpoint of a straight line. And in order to find the midpoints, again, you're given coordinates at A and B. It's the sum of the two x values at point A and point B divided by 2. And then the sum of the coordinates of the y values divided by 2. With all of your formulae, remember your signs are very important. You can lose marks by being careless with signs. So be very careful. Where there's a minus, use a minus. Where there's a plus, use a plus. All right. Gradients of a line. To find the gradient of a line between 2 points, your gradient y coordinate at point B minus the y coordinate at point A divided by the x coordinate at point B minus the x coordinate at point A. So that's your gradient formula. Now what I also want to remind you about, just touching on gradients, is that when we look at horizontal lines, so if this is your axis, or your axes, if you have a horizontal line, so that's just a line going straight through the y-axis, all right? The gradient of that line is equal to 0. Now, the reason for that, okay, hopefully you guys can see the reason for that, but remember, everywhere along this line, y is equal to some value. Let's just say y is equal to c, okay? Because your y coordinates at any point are exactly the same, when you use your formula, y coordinates at point B minus y coordinates at point A, it doesn't matter what your denominator gives you, your numerator will always give you 0, and therefore the gradient of a horizontal line is equal to 0. Now on the other hand, if you're looking at vertical lines, so there you have a line going straight through the x-axis, okay? So here we have x is equal to some value, okay? The gradient of that line is undefined. The reason for that, if you look at what's in your denominator, x coordinates at point B minus x coordinates at point A. all along this line, your x-coordinate is b. So if you have b minus b in the denominator, you're going to get something divided by naught. And we know that division by naught is undefined. So therefore, for vertical lines, your gradient will be undefined. All right? Still dealing with gradients. Remember, very importantly, that for the gradients of parallel lines, they have equal gradients. Okay, so parallel lines are the same distance apart, and the gradients of parallel lines are equal. And then when you're dealing with perpendicular lines, the product of the gradients of the perpendicular lines is equal to -1. So if you have gradient of line 1 times gradient of line 2, if you multiply them together, your answer will be -1. And we'll look at in detail when you go over questions and that, you will see an application of where the product of perpendicular lines is equal to -1. And later on in the show, we'll also have a look at an example where we tackle perpendicular lines and how we use the gradients to find the equation, or to find the gradient of the perpendicular line. Okay, that's given. All right. Let's go straight into question 1. Okay, here you're given the line joining point C is -2. The line joining point C, -2, 4, and dxy has a midpoint of m is 1 and -3. Find point D. Okay, so let's see what you've been given here. Okay, so we have, and I'm just going to do a rough sketch. We've got C is the point -2 and 4. All right. D is somewhere out here. We don't know what the coordinates of D are. But we do know, and they do tell us, that the coordinates of the midpoint, so that's exactly midway between point C and D, they tell us that those coordinates are 1 and -3. And they then want you to find the coordinates of D. So a very common question here, what we're going to be doing is using the midpoint formula and working backwards using that formula. Now remember, to find the midpoint of this line CD, we're going to say x-coordinate at point D plus x-coordinate at point C divided by 2 will give me the x-coordinate of the midpoint of line CD, and then y-coordinate at point D plus y-coordinate at point C divided by 2 will give me the midpoint of line CD. Now we need to create an equation with this, because remember, we've got that the x-coordinate can be written as x minus 2 all over 2. The x-coordinate of the midpoint, though, was given as 1. So therefore, we know that this value that we've worked out using the midpoint formula will eventually give us an answer of 1. Okay? I can then use that equation to solve for x. So I get x minus 2 is equal to 2. I just cross multiplied there. And we'll get x is equal to, take your minus 2 over to the right-hand side. We get 2 plus 2, which is 4. Okay? Similarly, for the y-coordinate, we see that an expression for that y-coordinate is y plus 4 over 2. And that's going to be equal to the y-coordinate of the midpoint, which we know is minus 3. So we make that equal to minus 3. We then cross multiply and we'll get y plus 4 is equal to minus 6. Therefore, y will be equal to minus 4 minus 6, which is minus 10. Okay. So now we can say the coordinates of D are x is 4 and y is minus 10. And guys, remember, with something like this, you can always go back and check. Now, if I've got the x value at point D is 4, let's see if it makes sense. If this is 4, I'll say 4 minus 2. That's going to give me 2. 2 divided by 2. So I'm just using this midpoint formula to see if I get this answer here. So 4 minus 2 is 2. 2 divided by 2 is 1. Correct. And the y value here we got was minus 10. Was that right? Y we got was negative 10, yeah. So if I say minus 10 plus 4, so using this one, minus 10 plus 4 would give me minus 6. Minus 6 divided by 2 is in fact minus 3. So what you can do is you can always get your points, your answers, and then just check and make sure, confirm that it is in fact the right values. All right. Okay, hopefully you all are remembering everything you've done so far with analytical geometry. You understand where to use your formula and you're ready for the rest of the show. But at this point, I think it's a good time to take a quick break.
Wow, Natasha, with all that being said, I'm sure you guys have just taken in a little bit too much information, but let's take a quick ad break and we'll see you guys after the break. Welcome back, Mindsetters. Hope you guys are all energized and refreshed from this wonderful break. And remember, guys, that we still have our Casio calculator competition running. All you have to do is simply log on to Curio and answer the test yourself questions correctly. And can we please just congratulate our winner, and that is Tebato Madimabi. Congratulations, Tebato. And remember, the competition runs until next week, Monday, so you still have plenty of time, so get yourselves clicking. Natasha.
All right, guys. Okay, so we're back now with a couple more questions. We've done a bit of midpoint formula. We're ready to use distance formula, gradient formula, and let's apply everything into one big question. This is question 2. Okay, in your diagram, you've got the vertices of quadrilateral F, G, H, I given. Okay, and it's also put and plot nicely on a plane for you. And we ask you firstly, calculate the lengths of sides F, G, H, I. So calculate the lengths. They don't tell you specifically. They just say of the entire quadrilateral. So therefore, you're going to have to use your distance formula and work out the lengths of each individual side. All right, so let's get cracking with that. So this is just a straightforward application, guys, remember, of your distance formula. And while you will be given the formula, you need to know when to use each of them. All right, so let's start with the length of side GH. And the only little trick here is, and the only way you can really get tripped up is if you make a mistake with your signs. Otherwise, it really is just a straightforward application of your formula. All right, so let's look at GH. I'm going to say the x-coordinate at G minus the x-coordinate at, the x-coordinates at H minus the x-coordinates at G, and square that entire thing. Then it's plus the y-coordinates at H minus the y-coordinates at G, and square that entire expression. So it's going to be 3 minus 1 squared plus 7 minus 5 squared. All right, so I'm going to get this is equal to 3 minus 1 is 2, 2 squared is 4, plus 7 minus 5, 2, 2 squared is 4. So this is going to give me root of 8. Okay? All right, so let's move on to the next one, which is finding the length of HI. So that's going to be equal to, and I'm just going to write it straight into the formula now without going through the whole step of x minus at G at H minus x coordinates at I. So here we're going to get 3 minus 7 squared plus 7 minus 2 squared. Okay, so that's the distance between those 2 points squared, and this is going to be the root of 3 minus 7 is 4, 4 squared is 16, plus 7 minus 2 is 5, 5 squared is 25. And because I'm doing all of this in my head, there is quite a huge possibility that I might add up incorrectly, and hopefully it's keeping you guys on your toes and you're awake and you're checking and you're making sure that I'm not making any silly mistakes. So this is going to give me 6 and 5, that's 11, carry 1, that's going to be 41. All right. So we've got HI, we've got GH, let's move on to FI. So again, just a straightforward substitution into your distance formula. The x-coordinate squared, the difference between the y-coordinate squared, and we're going to get, so it's going to be 7 minus 2 squared plus 2 minus 0 squared, so it's going to be 5 squared plus 2 squared, and that's going to give me the root of 25 plus 4, so that's going to be the root of 29. Okay. And lastly, we've got the length of GF, so it's going to be 1 minus 2 squared plus 5 minus 0 squared. So this is GF. It's going to be the root of, let's just add that in. Let's go back up there to remind you guys. It's going to be the root of 1 minus 2 squared plus 5 minus 0 squared. 1 minus 2 is just going to be negative 1 squared plus 5 squared. So that's going to give me 1 plus 25 is going to give me 26. All right. So now that we've got all the distances off this quadrilateral, we can already tell a few things. Like, for example, because all the distances, none of the opposite sides are equal, straight away I'm thinking, okay, this can't be a parallelogram, because in a parallelogram, remember, your opposite sides are equal. Okay, so you've got to be thinking as you go through the question in preparation of the last part of the question. Okay. And part B says, are the opposite sides of FGHI parallel? Well, we know they certainly aren't equal. Let's check out the parallel. Okay, so I'm going to do it up here. We've got the gradient of HG. Now remember, with your gradient, it's y2 minus y1 all over x2 minus x1. And the only thing here, guys, is be careful with your signs and remember to get your order correct. So if you're starting with the coordinates at point H, then you need to make sure you get both the x and the y coordinates down first and then go to point G. All right, so 7 minus 5 is going to give me 2. 3 minus 1 is 2. So that just gives me the gradient of HG is equal to 1. All right? Remember, if that side were to be parallel to this side Fi, then we know that the gradients are supposed to be equal. So let's check that out. We're going to have y coordinate 2 minus 0 all over 7 minus 2. And that's going to give me negative 2 over 5. So we can see that these are in fact not equal, so therefore our opposite sides, no, they're not parallel. Okay, and what you guys can check, and I'm not going to do it now, I'm going to leave it for you to do, is you can also go and check and you'll see that side HI is not parallel to GF. Okay, so I want you to prove that to yourself, that HI is not parallel to GF. Okay, so it's just a straightforward application of your gradient formula and remembering that if lines are parallel, then the gradients must be equal. Okay, part C, do the diagonals of FGHI bisect each other? Now, in order to understand what formula to use, you need to understand what are they talking about. When they say bisect each other, bisect means cuts in two equal pieces. So if they were to bisect each other, that means that the midpoint of diagonal GI will be exactly as the same as the midpoint of diagonal HF. So if they were bisecting each other, those diagonals will have the same midpoint. So let's check and see if that is in fact the case. Again, I'm going to work on the top here so that we can get everything into our answer without having to go up and down. Okay, so I'm going to look at the midpoint of HF. Midpoint HF. All right. So it's going to be x coordinate at point H plus x coordinate at point F. So it's 3 plus 2, which is 5 divided by 2. And then it's going to be y coordinate at point H plus y coordinate at point F, which is 7, and then divide by 2. So the midpoint of HF is 5 over 2 and 7 over 2. Obviously, if these diagonals bisect, then the midpoints of GI will have to be exactly the same. Midpoint of GI, it's going to be 1 plus 7, which is 8, divided by 2, which is 4. All right? And then it's going to be 5 plus 2, which is 7, divided by 2. Okay, so they've got the same y coordinate, but they don't have the same x coordinate. So in other words, the midpoints are not the same. So therefore, we can say that these lines do in fact not bisect each other. So the diagonals do not bisect each other. Therefore, they do not have the same midpoint. All right. Then lastly, they say, state what type of quadrilateral this is and give a reason for your answer. Now, guys, if you look at the proof and what we've just shown, we've shown that firstly, in part A, we've shown that your opposite sides are not equal. Okay. We've also shown opposite sides not parallel. And we've also shown that diagonals do not bisect each other. So we already see that there's really nothing special enough about this quadrilateral to fall into the definitions of the special quadrilaterals we've done: squares, rectangles, parallelograms, and the rest of it. So therefore, this is just an ordinary quadrilateral, and the reason for it is it doesn't have any of those special properties that we associate with a special quadrilateral. So it's just an ordinary quadrilateral, this one, FGHI. Okay. All right, so Queen, how are we doing on your side?
Well, mine sitters, remember that we've got the maths challenge question, and it seems like not a lot of you are actually aware of it. So please, guys, get your answers coming in. We actually are going to answer it at the end. And yeah, just give us your answers, get interactive with us. And also about the Casio calculator, all you have to do is follow the details on our Facebook page, and you just have to answer the test yourself questions correctly before you can win yourself this awesome Casio calculator. And that is it from me, Natasha.
All right, guys, so then we're going to carry on with question 3. Let's have a look at this one, and hopefully, as Queen suggested, you all get on board and you start answering that challenge question. All right, so we're given point A is -6 and 1, and B is the point 0, 3. You are asked to then find the equation of the line joining the 2 points, and then find the equation of the other line, CD, which is perpendicular to AB, and they give you the coordinates or where it's passing through. Okay. Now, you've got 2 points. Let's set this up on a system of axes. Okay, and I'm just going to roughly put the points down where they should be. So we've got A is the point -6 and 1. So A is -6. Let's just say that somewhere there. Y is 1. Right. And then we've got B is the point 0 and 3. So the X value is 0, the Y value is 3. That will be on your X axis. And we can just join those points up. All right, and we'll call this one here point B. And we are asked to find the equation of the line that passes through those 2 points. Okay, now remember, whenever you're looking for the equation of the line, you need 2 things. You need your gradient, and you need a set of points. Okay, so you need some coordinates. All right, you've got 2 points here. You've got point A and point B. Therefore, we can work out the gradient using our gradient formula. So therefore, I can say the gradient of AB is going to be y2 minus y1, so 3 minus 1, all over x2 minus x1. Now, this is what I was saying with your signs. You've got to be careful with your signs because it's not minus 6. Please use brackets. Otherwise, you may just forget to turn that sign around there. So I'm going to get 3 minus 1 on the top is 2, and then 0 minus 6, it's going to become 0 plus 6, which is 2 over 6, which will give me a third. All right, so therefore the gradient of this line is a third, okay? And I just want to remind you guys what you can do now to find the equation. We know the equation of a straight line is y is equal to mx plus c. So the one way you can find the equation is you can substitute your gradient into this, okay, and then substitute a coordinate in to find your y-intercept. Okay, the other formula you can use is this one, y minus y1 is equal to m times x minus x1. So in this one, you've got your gradient, you've got another point, and you can use that equation to find the equation of your straight line. In this case, remember c being your y-intercept, we were lucky because the y-intercept was in fact given to us in the question, because they said b is the point 0, 3. So what do we call it? When the x value is 0, right, this is called the y-intercept. So it is in fact our value of c. So therefore c is just simply going to be 3. So we'll get y is equal to a third x plus 3. Right. And then part B says, find the equation of another line, CD, which is perpendicular to this line, but passing through a completely different point. So if it's perpendicular, that means it's going to cut it at 90 degrees, right? So it's cutting it somewhere at 90 degrees. Okay, even though my line doesn't look very straight. In fact, let's straighten it out a little bit. There we go. Cutting it at 90 degrees, that's a bit better. All right, and this is your line CD. Okay, they give us a point. They give us that this line is passing through x is minus 3 and y is 6. So let's just say that's somewhere there. That's a point on the line. That's minus 3, 6. They want us to find the equation of CD. Remember, you're finding the equation of the straight line. You need a gradient. You need a set of coordinates. You've got the coordinates. You don't have the gradient. So how do you find the equation of this line that's now perpendicular to another line? Remember, we discussed this in the summary at the beginning of this lesson. In order to find the gradient of the perpendicular line, we take into account that the product of the gradients of perpendicular lines is minus 1. So therefore, we know the gradient of AB is a third. That gradient of AB times the gradient of CD, the product of those two must be equal to minus 1. So what I'm saying is the gradient of AB times the gradient of CD must be equal to minus 1. Now we know that the gradient of AB is a third, right? So a third times the gradient of CD is equal to minus 1. Okay, is equal to minus 1. Therefore, the gradient of CD, I simply divide both sides by a third. So I get minus 1 divided by a third. You tip and times, and you get an answer of minus 3. All right, so therefore the gradient of CD is minus 3. You could also, if you didn't want to do this in the whole long working out version, since you know the product of the gradients is minus 1, if the one gradient is a third, all you do to get the other gradient is you tip these around, okay, so it's going to become 3 over 1, and you change the sign. So this is positive, so you change the sign to a negative, and a third times its inverse, negative 3 over 1, will give me negative 1. Okay, so you could also just do it by looking. So the gradient of line CD is minus 3. So now I'm looking at, this is part B. We know the gradient of CD is minus 3. I need the equation. I've got y is equal to mx plus c. Or if you don't want to use that one, you can use y minus y1 is equal to m times x minus x1. I've got a set of coordinates, so I can substitute those in. Remember, they told you it passes through minus 3 and 6. So therefore, y minus So minus 3 and 6, that was your coordinates. So it's going to be y minus y1 being the y value of your coordinate that was given, is equal to m, which is your gradient, times x minus x1, which is the x value you were given. Again, use brackets so that you don't mix up your signs there. You get y minus 6 is equal to minus 3x. Minus times a minus is a plus 3. Take the negative, multiply it through. So plus 3 times negative 3 is going to give me negative 9. All right. Take the 6 over to the other side, so I get minus 3x minus 9 plus 6 will give me minus 3. All right, and that's the equation of line CD. Okay, so guys, that's a nice question. We've looked at in the last two questions how to use gradients of parallel lines, how to find gradients of perpendicular lines, and how to find the equation of a line. So all quite a bit of information for you guys to take in. So Queen, I think it is time for a quick break.
All right, Mindsetters, let us take a really, really quick ad break, and then we'll see you after this. Welcome back, Mindsetters. Hope you guys are ready for the next segment of the show. And we're going to do our challenge question. Natasha?
All right, guys, so hopefully I haven't heard if you guys have answered any of the challenge questions yet. Queen, have they been answering?
We have a few answers from Andile and Katlejo Moses. Yeah, we've got about 5 Mindsetters who have already answered the question. But Mindsetters, please get in touch with us.
All right, guys, so hopefully if you've tried the challenge question, you're ready and you've got your answers and you're ready to mark them and check if you're correct. Let's have a look. Let's go straight into it. So here you were given PQRS is your quadrilateral, and you were given the points. You were asked to find lengths, gradients, midpoints, and then state what if it is a parallelogram. So what type of quadrilateral is it? All right. I'm going to put the points down on a diagram, and we'll refer to it as we go through this question. Okay, we've got that point P is 0 and minus 3. So x is 0, y is minus 3. So let's say that's somewhere there. That's point P. We've got Q is x is minus 2 and y is 5. X is minus 2, y is 5. So let's say that that is there. Okay, and I'm just going to write the coordinates as we put our diagram together. Here x was minus 2, y was 5. And we had r, x is equal to 3, and the y value was 2. So x is 3, y is 2. X is 3, y is 2. Let's just, we want that below Q. There we go. Okay, so I'm going to say that somewhere there, and that was the point R. X was 3, y was 2. And then we had x is 3 and y is minus 2. So these, I'm going to have to just erase this of P so that we can put these coordinates down. Here you've got x is 3 and y is minus 2. Okay, so just a rough idea of what's going on the diagram. Right. This is just for our, it's not for marking purposes, it's really just for us to get an idea, a picture in our heads to guide us as we go through this question. Okay, so we're just going to join those points together. There we go. Okay, so that's our quadrilateral. The first part says, find the length of QR. So they want the length of QR. Remember, it's a straightforward application of your distance formula. So we know the length of QR. Remember, the distance formula says to find any length, it's the square root of the difference in the x values squared plus the difference in the y values squared. All right, so using Q and R, it's going to be x1 minus x2, so it's going to be 3 minus minus 2, and you note that I've put the minus 2 in brackets so that our signs are correct, and then it's going to be 2 minus 5 all right, so I get the root of 3 minus minus 2, so it's going to become 3 plus 2, which is 5 squared, plus 2 minus 5 is negative 3 squared, so we get the square root of 25 plus 9, which will give me the root of 9 and 5, that's going to give me 34. Alright, so we've got QR is the square root of 34. Alright, and I'm just going to write that distance here, just in case we need to come back to it later on. Okay. Part B says find the gradient of PS. So PS, another side of the quadrilateral. So for the gradients, I'm going to use gradient formula. And we're going to say the gradient of line PS is going to be equal to the y coordinates. And remember, guys, order is important. So if you start at S, you need to keep both an x, y values starting from point S. Okay, so don't swap around in between. All right, so I'm going to say y coordinates at point S, and this was a negative 2 there. Y coordinates at point S minus y coordinates at point P. So y coordinates at S minus y coordinates at P all over x coordinates at point S minus the x coordinates at point P. And I'm going to get minus 2 minus minus 3. So it's minus 2 minus minus 3 all over 3 minus 0. Alright, so that gives me minus 2 plus 3, which is just 1, all over 3. So therefore the gradient of PS was a third. Okay, so we've got the gradient of that line PS being a third. They then say to you, find the midpoint of PR. So we're really going through all of the different types of questions you could be asked when you're given a quadrilateral. Find the length, find the midpoint, find the gradient. These are typical questions, and you need to be able to understand what formula to use when. All right, so now we're looking at the midpoint of line PR. So that's the diagonal of this quadrilateral. Okay, so for the midpoint of PR, this is part C. Midpoint, and we're looking here for PR. Again, it's going to be x coordinates at point P plus x coordinates at point R. It's the sum of the two x coordinates divided by 2, and then the sum of the two y coordinates divided by 2 will give you your midpoint. All right. So if we look at this, we've got PR. It's going to be 3 plus 0 divided by 2. All over minus 2 minus 3 divided by 2. It's minus 2 minus 3. Just want to make sure I'm taking the right coordinates there. No, they are swapped over to point S. So it's going to be 3 plus 0 divided by 2, and then 2 minus 3 divided by 2. Minus 3 plus 2. Right, so that's minus 3 plus 2 divided by 2. And that's going to give me 3 over 2 and minus 1 over 2. Okay, so we've got the midpoint of this diagonal PR. All right, we've got that midpoint there. The next part of the question says, Is PQRS a parallelogram? Now remember, in order for you to answer this question, you need to remember what the properties of a parallelogram are. So for example, all four sides are equal, or sorry, not equal to each other. The opposite sides are equal to each other. Opposite sides are parallel, or you have one pair of opposite sides parallel and equal, or you have the diagonals bisecting each other in order to get a parallelogram. So there's a whole lot of reasons that you can choose from. You look at what we've got here and you decide with any one of these, what will I prefer to use? Now, if I, for example, use the fact that we've worked out length QR, all I simply need to do is show that the length of PS is not the same, and then since opposite sides will not be equal, it will not be a parallelogram. Alternatively, if they are equal, you will then need to also show that RS and QP are the same. Okay? So that's one option. We could use the lengths. If we're going to go with gradients, so we've got the gradient of PS. Remember, in a parallelogram, your opposite sides are parallel. So if I've got the gradient of PS, I'm also going to need to work out the gradient of QR. And if those are the same, then the opposite sides are parallel. Then you will need to go on to work out the gradient of QP. And if that's the same as RS, then opposite sides are parallel. Therefore, it is a parallelogram. Or we've got the midpoint of PR. If you find the midpoint of QS, remember diagonals of a palm bisect each other. So if you find the midpoints of PS and it's not the same, then obviously this will not be a palm, because in a palm diagonals do bisect each other. All right. So guys, I'm going to show you part D using the midpoints, and then if we've got time, I will use one of those other two to show you another way you could have done this. All right. So all I'm going to do is work out the midpoint of QS. And obviously, if that's not the same as the one we've just worked on here, then this is not a parallelogram. Okay, so QS, I'm going to say minus 2 plus 3. I'm working out the midpoint, so it's the sum of the x values, minus 2 plus 3 divided by 2. And then it's going to be the sum of the y values, so it's going to be 5 minus 2 all over 2. And we will end up with a half and 3 over 2. Okay, so as you can see, your midpoints, they look similar, but they're completely different. So therefore, we do not have the same midpoint, right? So since we can say, okay, so we've disproved. So since the diagonals do not bisect each other, PQRS is not a parallelogram. Okay, and I'm just going to abbreviate that to POM. So since the diagonals do not bisect each other, we've shown that if the diagonals do not bisect, there's no way this can be a parallelogram. So before I try and show you a different way to do that part D, I want to quickly check with Queen and see if we've got any questions of yours that we can go over, maybe things you didn't understand in the show, and maybe we can help them now, Queen.
Wow, Natasha, this is very interesting and very pleasing, because most of our mindsetters actually got the challenge question correct.
Fantastic, well done.
And we've also got a comment from Ketla who says, "Thank you, Natasha. Please thank her for me." So that means you're doing a great job, Natasha. And so far, no questions. So I guess we are actually on a good road.
Okay, so no questions thus far. Hopefully it means that all of you guys are understanding. It gives me about 5 minutes or so just to show you a different way to answer part D of this. All right, so remember I was saying to you guys, if you show that the diagonals, if they do not have the same midpoint, which means they do not bisect, then this is not a parallelogram. The other way we could do it is by showing that the opposite sides are not parallel. And what I want to do is I want to use the parallel line things, because it's something that comes up over and over again. So remember, we've worked out the gradients of PS, okay? Now, in order to show it's not a parallelogram, you simply need to show that PS is not parallel to QR. How do we do it? We've worked out that the gradients of PS was a third. Okay, so that was part B. We worked out that this gradient was a third. I now need to work out the gradient of QR. All right. So remember, your gradient is going to be y2 minus y1 all over x2 minus x1. And again, use your brackets so that your signs don't get confused there. 2 minus 5 is negative 3. All over 3 plus 2 is 5, and you get the gradient of QR is negative 3 over 5. So guys, that would be enough. Another way to show it is, you'll say, well, the gradients of QR and the gradients of PS are different, but if this was a parallelogram, they're supposed to be the same, because opposite sides of a palm are parallel. So therefore, these will not be parallel, so it couldn't be a palm. Okay? You could do it with any of the two sides. So if we tried the gradient of PQ, or QP, we would get 5 minus 3 all over minus 2 minus 0, and that will give me 8 divided by minus 2 is minus 4. All right, and then again, if I want to show that these opposite sides are in fact parallel, then I need the gradient of SR to be exactly the same. So to work out the gradient of SR, I say 2 minus 2 all over 3 minus 3. And over here, okay, this was an example of something we spoke about earlier on, because points R and S are on the exact same vertical line. So obviously this is just a vertical line going straight through the x-axis. And if you try to work out your gradient, you see that you get an undefined answer, because you get naught in your denominator. So there's no way that this is going to be parallel to that line, because the one gradient is undefined. So the one is perpendicular to the x-axis and the other one is not. So either way, you can show that those sides are not parallel, opposite sides are not parallel, therefore it cannot be a parallelogram. All right, okay guys, so we went through a couple of ways that you could answer this question. I hope you've all followed along and you've all had a great time with the challenge question, and you're ready to hand over back to Queen. But before we do that, thank you for joining us, guys. Queen, it was nice having you with me today.
Thank you so much, Natasha. A quick question from Katlego Moses, actually. He asks, why is the product of two perpendicular lines equals to -1?
The product, okay, we went through this in the beginning. That's something you've just got to learn. The product of the multiple of the two perpendicular lines is equal to -1, and I did show you before it's because the one gradient will always end up being the negative inverse of the other one. So if, for example, the one gradient was a half, the other one will always be the negative inverse, and if you multiply those together, it will be -1. You can show this to yourself if you take 1,000,000 perpendicular lines. If you have the time, multiply the gradients together, the product will always be -1. So that's just a rule to help you guys simplify perpendicular gradient questions. All right,
guys. Thank you so much, Natasha. You've been a very, very great teacher with us in studio. And guys, hope mindsetters all at home, I hope you guys have learned yourself some great things about analytical geometry for all our grade 10s. And we have another competition for you mindsetters, and it is the SA Water Game competition, where you stand yourself to win up to 5,000 Rand in cash. Yes, that is how much love we have for you mindsetters. But for more information and details, we'll be posting all the information on our Facebook page, so you can just go on our Facebook page and look up for all the details on how the competition goes and how you can enter, and how, of course, you can get to win yourself all those awesome cash prizes. And we've got other prizes up for grabs, so don't miss out on that. Quickly, as soon as possible, go onto our Facebook page and check out the competition. Well, mindsetters, that is it from us. Natasha, You've been very, very awesome.
Thank you.
And I feel like all our mindsetters are loving you. You've got great comments coming from you guys about Natasha and all her skills and all that she's been teaching us in studio today. And guys, that is it. So mindsetters, don't despair. We will be back again next week. So for now, it is going to be a very, very, very welcoming and warm goodbye from myself, Queen Matuso. Don't despair. You'll join us later again. Thank you, guys.